Okay, picture this. A flash of light from like halfway across the universe. It's brighter than a billion suns, but it's over in less than the blink of an eye. For years, astronomers have been catching these signals, and they call them fast radio bursts, or FRBs for short. Honestly, they're one of the biggest puzzles in the cosmos. So today, we're going to dive in and try to figure out the absolutely mind-bending engine that must be powering them.
So, here's how we're going to tackle this. First, we've got to bust a popular myth about these things because it's really holding back our understanding of their true power. After that, we'll start following the scientific breadcrumbs, using what's called a four-pillar framework to build a picture of the engine behind them. We'll see how one single theory just clicks and solves the whole puzzle. And then, for the big finish, we'll see how solving this mystery has given us an incredible new tool to explore the universe.
All right. So when these bizarre signals first started showing up, how did scientists even begin to explain them? Well, for a long time, there was this one simple analogy that pretty much everyone used. It was almost a little too comfortable.
And this was the idea. It's like a distant lightning strike in a radio telescope. It kind of makes sense at first, right? A super quick, bright flash from really far away. It was a nice, tidy idea. It suggested these were just, scaled-up versions of stuff we already knew about, like maybe big flares from a star. But, and this is a huge but, that idea of modest energy, oh man, it could not have been more wrong.
So yeah, forget the idea of a little cosmic spark. As our telescopes got more and more sensitive, the new reality just smacked us in the face. These things are powered by an absolutely extreme engine. We're talking about the sun's entire energy output for a whole week. Boom. Released in less than a second. This wasn't just a bigger flare. This was a completely different kind of beast, a true cosmological mystery that needed a whole new explanation.
Okay, so if it's not a lightning strike, then what are we dealing with? Just how much energy are we really talking about here? And this is where the numbers get so big they're almost meaningless. It's truly mind-boggling. So let's try to wrap our heads around it.
All right, here's the number, 10 to the 40th power ergs. Now, an erg is a ridiculously tiny unit of energy. You need something like 100 trillion of them just to light a light bulb for 1 second. So we're talking about a 1 with 40 zeros after it. A number that big is just a number on a page, right? So what does that kind of power actually look like in the real universe?
Well, here's the best way to picture it. Imagine you could capture all the energy our sun puts out, every single bit of light, heat, everything, for an entire week. Now bottle all of that up and release it in a single flash that lasts less than 5 milliseconds. That is the power we're talking about with an FRB. So it all boils down to one huge question. What in the entire universe is powerful enough to do that?
Now, when you're faced with a puzzle this huge, you can't just start guessing. You need a plan, a framework. And that's exactly what scientists did. They broke the problem down into 4 key questions, or as they call them, the 4 energetic pillars. Think of this as their roadmap for hunting down the source. Okay, pillar 1, the energy reservoir. Simply put, where is all this power coming from? Pillar 2, coherent emission. How is the light produced so ridiculously bright? I mean, unbelievably bright. 3, relativistic amplification. What's acting like a cosmic particle accelerator, kicking these particles up to almost the speed of light? And finally, 4, propagation effects. What clues can we get from the signal's long journey to get to us?
All right, let's start building our case. By working through each of these 4 pillars, scientists could start crossing suspects off the list, really narrowing down the field of cosmic culprits.
So let's start with pillar 1, finding that energy reservoir. Let me tell you, the list of things in the universe that can pack this kind of punch is incredibly short. We are talking about the most violent extreme events you can imagine. Things like giant flares erupting from magnetars. These are neutron stars with magnetic fields that are just insane. Or maybe the cataclysmic crash of 2 neutron stars merging together. Or even weird events happening in the winds shooting off of young pulsars. Whatever it is, the sheer luminosity, the power output, has to be just absolutely breathtaking.
Okay, on to pillar 2, that impossible brightness. The temperature you need to explain this signal is something like 10 to the 37th Kelvin. To put that in perspective, the core of our sun is a measly 15 million Kelvin. This number isn't just big, it's physically impossible. It breaks physics, unless something very special is happening called coherent emission. The best analogy is a choir.
If a bunch of particles all radiate on their own, it's just noise. But if they all radiate perfectly in phase, together, like a perfectly synchronized choir, the signal they produce is millions of times brighter. It's the only way to get a signal this intense.
The last two pillars really start to tighten the screws. Pillar 3, the amplification, tells us that whatever is making this light, it has to be accelerating particles to nearly the speed of light. We're talking Lorentz factors in the hundreds or thousands. And it has to do it in a really small space, smaller than our sun's own magnetic bubble. And then pillar 4, the journey itself, gives us forensic clues. As the signal travels through space, it gets stretched and twisted by all the stuff between galaxies. By studying that distortion, we can basically reconstruct the crime scene and learn about the extreme environment where the FRB was born.
So you take all of these clues together, right? You've got the colossal energy reservoir, the physically impossible brightness, the need for a super powerful particle accelerator, and all the forensic evidence from the journey, and suddenly all the arrows start pointing in one very specific direction.
And that prime suspect, the one that fits the profile perfectly, is the magnetar. Let's just run down the checklist. You need an extreme energy source? A magnetar's magnetic field, 1,000 trillion times stronger than Earth's, has that in spades. You need to explain why some of them repeat? Well, that same magnetic field is incredibly unstable. And that extreme brightness? You can get that from something called a synchrotron maser happening in relativistic shocks near the magnetar. It fits. It checks every single box. The magnetar model solves the whole puzzle.
So there we have it. We've got our culprit. But you know what? The story doesn't stop there. Not by a long shot. Because the moment we figured out what FRBs are, it completely changed what we can do with them. This is the really incredible part. In just a few years, FRBs have transformed from this total enigma into a powerful new tool. They're not just some weird cosmic glitch anymore. Think of them as a flashlight, a standard candle that we can now use to probe the vast, dark emptiness of the universe. And what can we do with this new tool? So much! We can actually use them to map out the cosmic web, that incredibly faint structure of matter that connects all the galaxies. We can study the physics of magnetic fields so extreme we could never, ever create them here on Earth. We get to watch the evolution of these compact objects like neutron stars and even see how they behave in binary systems. It's amazing. This one little mystery has blown open whole new areas of research.
So think about that. A weird, millisecond-long blip of static, once a total mystery, has now become one of our most powerful tools for understanding the entire universe. It really makes you wonder, doesn't it? What other incredible secrets are out there, hiding in plain sight, just waiting for us to find the right way to listen?